Hello, this is Gauri. Our today's topic is game theory. Let's begin with the general introduction. Game theory was developed by mathematician John von Neumann and economist Oscar Morgenstern in 1944 to evaluate situations where individuals and firms have conflicting objectives. In oligopoly and duopoly markets, firm must consider the effects of the decisions on other firms and anticipate how other firms will respond. Thus, the goal of the firm in oligopoly market is to earn economic profits by outguessing the rival firms. The game theory has helped to understand more clearly how the firms behave in oligopoly markets. But what do you mean by game theory? Game theory attempts to study decision making in situations where two or more intelligent and rational opponents are involved under conditions of conflict and cooperation. Such situations, basic to oligopoly market structure, game theory seek to determine a rival's most profitable counter strategy to one's own best moves to formulate appropriate defensive measure. For example, two firms are involved in a competition to maintain their market share. Then, a price cut by the first firm will invite similar reaction from the second firm. This will in turn affect the sales and profits of the first firm, which will again have to develop a counter strategy to meet the challenges from the second firm. The game will thus go on. Game theory helps in determining the best course of action for a firm in view of the expected counter moves from the competitors. The competitors in the game are called players. A game is thus a competitive situation where the market players pursue their own interest and no player can dictate the outcome. Games that firms or players play can be of two types. First is cooperative games. In this type of games, players can negotiate a binding contract to plan joint strategies or actions. Second is non-cooperative games. In this type of games, it is not possible to negotiate a binding contract to plan a joint strategy. The assumptions of game theory are: first is the possible set of actions or strategies available to each firm is finite. Second, each player or firm is aware of both the strategies available to himself and to his opponent. Third is each player is intelligent and rational, thus having complete knowledge preference order of his moves and that of his opponents, which he uses to select his best moves. Fourth is players aim to maximize gain or minimize loss. Fifth, player A's gain is player B's loss and vice versa. If the gain is exactly equal to loss, it is called zero-sum game. Now, let us discuss some basic definitions and terminologies. Every game theory model includes players, strategies and payoffs. Therefore, let us first understand these concepts. First is strategy. A strategy is the course of action taken by one of the participants, that is a firm, in a game or market. Each player of firm is a decision-making unit who decides about the rule of the game. A strategy is a complete specification of the plan of action by the firm or player after taking into consideration all possible reactions of its competitors as they compete for profits or other advantages. Since there are only a few firms in the industry, actions of each firm affects the others, and the reactions others must be kept in mind by the first firm while choosing its own best course of action or strategy. There are two types of strategies. First is pure strategy. If the player or firm selects same strategy or only one course of action every time in response to his competitor's action, it is called pure strategy. Use of this type of strategy requires that each player has complete knowledge of the strategy of his opponent. Second is mixed strategy. In many games, pure strategy would be a very poor choice. The use of mixed strategy means that the player do not use a single strategy but a mix of strategies. Each player always keeps the other players guessing about the course of action that the firm is going to select in a particular situation. Mixed strategies involve a player randomly choosing among pure strategies according to given probabilities. A mixed strategy is a strategy in which a player makes a random choice among two or more possible actions based on a set of chosen probabilities. For example, in a cricket match between two countries, say India and Australia, an Indian bowler always bowls differently each ball in an hour. Then it is said to have that he is using a mixed strategy, because he keeps the opponent batsman guessing about the type of ball that he is going to face from the bowler. Mixed strategies can be important in many settings and sometimes they are used to reduce cost. It would be very expensive to audit every income tax return. Therefore, the income tax department chooses individuals at random after using some pre-selection criteria for audits. Although the vast majority of returns are not audited, the possibility of an audit encourages tax compliance among the general population. Second is payoff. It is the result or outcome of the strategy. For each strategy adopted by a firm, there is usually a number of strategies available to the rival firm. The payoff is the outcome or consequence of each combination of strategies by the two firms. The payoff is usually expressed in terms of profits or losses of the firm that as a result of firm strategies and the rivals' responses. The table giving the payoffs from all strategies open to the firm and the rivals' responses is called payoff matrix. In this particular table, first number in each cell always refers to firm A and the second number always refers to firm B. If firm A advertises but firm B does not, A makes a profit of 30 and B makes no profit. If firm B advertises but A does not advertise, A and B make profit of 12 and 16 respectively. This is the table, payoff matrix. Third is optimal strategy. A course of action or plan which puts the player or firm in the most preferred position irrespective of strategy of his competitors is called its optimum strategy. Any deviation from it results in a decreased payoff for the player. Move on to the next topic, that is dominant strategy. How can a firm decide about the choice of its optimal strategy? A particular strategy may be successful or more profitable if competitors make a particular choice or decision, but will not be successful or more profitable if they make other choices. However, a dominant strategy is one which will be successful or optimal for a firm regardless of what other firms do. It is that strategy which will be most beneficial to a firm no matter what strategy the rival firms adopt. Thus, the dominant strategy is the optimal choice for a player no matter the opponent does. To understand the concept of dominant strategy, we will take an example given in the table. Suppose there are two firms A and B. There are two strategies for each firm to advertise or not to advertise. Firm A expects to earn higher profits if he advertises than if he does not. For possible outcomes are shown here in this payoff matrix. What strategy should each firm choose? Let us consider A first. If firm B advertises, firm A will earn a profit of 4 if he also advertises and 2 if he does not. Therefore, firm A should advertise if firm B does. If firm B does not advertise, firm A will earn a profit 5 if he does advertise and profit of 3 if he does not. This shows that A should advertise irrespective of whether firm B advertises or not. Firm A profit will be higher if it advertises rather than if he does not, regardless of what firm B does. Therefore, it is said that the dominant strategy for firm A is to advertise. Similarly, if we analyze firm B's strategy given strategies of the firm A, we will find that firm B has a dominant strategy to advertise, irrespective of what strategy firm A adopts. Thus, in this case, A and B, both firms have a dominant strategy of advertising. Here, final equilibrium exists for both firms irrespective of whether firm A or firm B chooses its strategy first or if both firms decide on their best strategy simultaneously. Now, let us discuss next topic, that is Nash equilibrium. Not all games have a dominant strategy for each player or firm. In fact, in real life, it is more likely that one or both players do not have a dominant strategy. This is shown in this table. Here firm B has a dominant strategy, but firm A does not have a dominant strategy. The dominant strategy for firm B is to advertise irrespective of whether firm A advertises or not. For example, if firm B advertises, firm A earns profit of 4 if he advertises and profit of 2 if it does not. Thus, if firm B advertises, firm A should also advertise. On the other hand, if firm B does not advertise, firm A earns profit of 5 if it advertises and 6 if it does not. Thus, firm A should advertise if firm B does and should not advertise if firm B does not. Thus, firm A no longer has a dominant strategy. What firm A should do depends on what firm B does. In order to firm A to determine whether to advertise or not, firm A must try to determine what firm B will do and advertise if firm B does and not advertise if firm B does not. As the firm A knows the prey of matrix, it can find out that firm B has a dominant strategy of advertising. Therefore, the optimal strategy for firm A is also to advertise. This is Nash equilibrium, named after John Nash, the Princeton University mathematician and 1994 Nobel Prize winner in economics. The Nash equilibrium is the situation in which each player chooses his optimal strategy given the strategy chosen by the other firm. In this example, the strategy to advertise for both the firms is Nash equilibrium. This is because it is given that firm B chooses his dominant strategy of advertising. The optimal strategy for firm A is also to advertise. Here, it is important to note that when both the firms had dominant strategy, each firm was able to choose its own optimal strategy regardless of strategy adopted by its rival firm. In this case, only firm B is a dominant strategy and firm A does not have any dominant strategy. Therefore, firm A is not in the position to choose its optimal strategy independently of firm B's strategy. Next topic of the discussion is prisoner's dilemma. Oligopoly firms often face a problem called prisoner's dilemma. This refers to the situation in which each firm adopts its dominant strategy but could do better. That is, each can earn larger profits by cooperating. Prisoner's dilemma is an example of non-cooperative game. A game is considered non-cooperative if it is not possible to negotiate with other participants and enter into some form of binding agreement. When firms in the oligopoly markets use pricing strategy to compete with each other for profits, they are said to be engaged in non-cooperative games, because they are legally prohibited by competition laws for coordinating their prices. In some cases, non-cooperative games can result in outcomes that are undesirable for the participants and the society. One such example is prisoner's dilemma. This model takes its name from the story of two persons who were jailed for the crime they allegedly committed. Two suspects were arrested for an armed robbery, and if convicted, each can receive a maximum sentence for 10 years imprisonment. However, unless one or both suspects confess, the evidence is such that they could be convicted only for 1 year for possessing stolen goods. These suspects are separated and interrogated by the police, and no communication is allowed between them. Each is told by the police that if he does not confess and other suspect does confess, then he will be convicted and put in jail for 10 years. But if he does confess and implicates his friend, then his jail sentence will be only for 1 year. If both suspects confess, each will get imprisonment for 5 years. The payoff matrix in terms of years of imprisonment is shown here in this table. This table shows that the dominant or the best strategy for the suspects is to confess. Thus, if suspect B confesses, suspect A gets 5 years in jail if he confesses and 10 years in jail if he does not confess. If suspect B does not confess, suspect A goes free if he confesses and gets 1 year imprisonment if he does not confess. Thus, irrespective of the strategy adopted by suspect B, the dominant or the optimal strategy that A can adopt is to confess. Similarly, for suspect B also, the dominant strategy is to confess. If suspect A confesses and suspect B also confesses, then B gets jail term for 5 years, and if B does not confess, he gets jail term for full 10 years. On the other hand, if suspect A do not confess and suspect B confesses, B does not go to jail, but if B does not confess, he gets jail term for 1 year. Therefore, confessing is also the best or dominant strategy for suspect B. Both suspects, thus adopting their dominant strategy of confessing, ends up into the jail for 5 years. However, if both suspects do not confess, then they both will go to jail only for 1 year for possessing the stolen goods and not for full 10 years as the evidence is only circumstantial. But each suspect is afraid that if he does not confess, the other suspect does confess. He will get jail term for 10 years. Only if each suspect was sure that he will not confess and other suspect will also not confess, they will go to jail only for 1 year. However, as it is not possible for them to somehow meet or communicate and enter into an agreement of not confessing, each suspect adopts his dominant strategy of confessing and thus ending up with 5 years of imprisonment. It is important to note that even if they enter into an agreement of not confessing, it cannot be enforced, hence both convicts end up with the 5 years in jail. Although not confessing is the best joint strategy because they are involved in non-cooperative game and cannot influence what other suspect does, they end up with a decidedly non-optimal outcome. Moving ahead with next topic, that is price competition and prisoner's dilemma. The concept of prisoner's dilemma is useful to analyze price and non-price competition in oligopoly markets as well as incentive to cheat, that is the tendency to secretly cut price or sell more than its allocated quota. Here in this table, an example of price competition is given which is similar to the example of prisoner's dilemma. The payoff matrix shows here that if firm B charged low price, that is say ₹6, firm A would earn a profit of ₹2 if it also charged low price, that is ₹6 and 1 if it is charged higher price, say ₹8. Similarly, if firm B charged a high price of ₹8, firm A would earn a profit of ₹5, it is charged low price, and ₹3 if it also charged high price, that is ₹8. Thus, firm A would adopt dominant strategy of charging low price. From firm B's point of view, if firm A charged low price, firm B will earn a profit of 2 if also charged low price and profit of 1 if it charged high price. If firm A charged high price and firm B charged low price, it will earn a profit of 5 and profit of 3 if it also charged high price. Thus, firm B would also adopt its dominant strategy of charging low price. Thus, the firms are in prisoner's dilemma. Each firm will charge low price and earn a lower profit because if it charged higher price, it cannot trust its rival to also charge the higher price. Therefore, the net result is that both firms by charging lower price end up with lower profits compared to what they can earn by cooperating and thus making an agreement about their respective pricing policy and overcoming the dilemma. The concept of prisoner's dilemma can be explained with the help of another phenomena of resource waste from advertising in oligopoly markets. For simplicity, it is assumed that there are two firms with two strategies regarding advertisement expenditure: low level of advertising or high level of advertising. The payoff matrix for 4 possible combinations of strategies are shown here in the table. If firm A advertises at a low level, its profit is ₹30 crores if firm B also advertises at a low level, and ₹10 crores if firm B advertises at a high level. If firm A advertises at high level, it earns a profit of ₹40 crores if firm B advertises at low level, and ₹20 crore if firm B advertises at high level. Thus, the minimum profit from low-level advertising is rupees 10 crores. The table shows that a high level of advertising will guarantee firm A at least rupees 20 crores profit. Therefore, the best strategy for firm A is to advertise extensively. Similar logic applies to firm B also, for whom high level of advertising earns him more profit. Thus, both firms opt for high level advertising and earn profits of rupees 20 crores each. However, a joint decision of not advertising or low advertising through cooperation can lead to higher profits of rupees 30 crores for each firm. But neither firm dares to select a strategy of low advertising, because if the other firm selects a strategy of high advertisement, he will end up with a profit of rupees 10 crores. The result is that both the firms can earn less profit and waste resources on mutually offsetting advertising. Let's summarize at the end. This discussion on game theory have explained how this concept can be used to explain the behavior of the firms in oligopoly and duopoly markets. It shows that it is necessary to understand the behavior of the firms when it is put into game theoretical situations. The players in the game are the competing firms, and their actions are the strategies that they may use or they may adopt depending on the action of their rival firms. The firms may or may not have an optional strategy. If they have an optimal or the best strategy, irrespective of the strategy followed by their rivals, they are said to have a dominant strategy. If the firm do not have a dominant strategy, they can still have an optimal strategy depending on the strategy adopted by the other firm, and this is called Nash equilibrium. The behavior of the firms where they cannot jointly decide their best or most profitable strategy are known as non-cooperative games. These types of games or behavior can be explained by the concept of prisoner's dilemma. Thank you.